Welcome back. Today we're talking about similar figures, and this is just the first part. We're going to use proportions to show that there's a relationship between lengths of corresponding sides and prove that figures are similar to each other. So when we're talking about shapes, we've talked about whether they're congruent or whether they're similar. Remember, if they're congruent, they have the same shape and the same size. However, if they're similar, they're the same shape, but not necessarily the same size. There are two factors that we have to prove to make sure that shapes are indeed similar to each other. The first one is that their corresponding angles have the same measure. This means that their matching angles are congruent to each other. They have the same measurement to each other, okay? So that's the first most important thing. Again, angles have the same measurement to each other. The second part that is necessary to prove that shapes are similar is that the lengths of their corresponding sides are proportional. That just means that the lengths of one shape are proportional to the lengths of the other shape that are on the same side. Their matching sides are proportional to each other. So lengths are proportional. All right, go ahead and pause the video and copy this into your notebook. Well, let's look at these two triangles and see if they are proportional to each other, if they are similar to each other. So corresponding angles mean that they're matching angles for each shape, and corresponding sides are the same thing, that one side of one shape is in the same location as the side of the other shape. So here we go. Corresponding angles, they're saying that this angle is it matches this angle, that they're in the same location, and for corresponding sides, they're saying this side that we're pointing to is in the same location on its shape as that one. That makes them corresponding or matching to each other. Okay, so we said if they are indeed similar, then their first thing is that their angles are congruent to each other. So we have 48 for this one, 48 for that one. That's true. This one's 66, and the corresponding one over here is this one, and that's 66. Yes, they're congruent. And this one is also 66, which matches this one over here, which is 66. So, yes, we've just proved that their corresponding angles are indeed congruent to each other, the same measurement. Now we want to see if their corresponding sides are proportional. So, let's go ahead and set up a proportion to prove it. Now, remember, when we're setting up a proportion, we want to identify what are the parts that we're comparing. So that's the first thing. So we have a large shape or a big shape, excuse me, and we have a smaller shape. So we're comparing the big to the small. So I'm going to go ahead and write that big one to the small one. All right. So my big one for corresponding sides, my arrows already show I have 75. So 75 for my big one, and 50 for my small one, so 75 to 50. And let's pick two more corresponding sides. So I'm going to go ahead and go over here to 51. So 51 on my big shape, and it corresponds to 34 on my small shape. I'm sorry, 34. Now, if they are similar to each other, that means they have to be proportional. So we've talked about different ways to show that they're proportional, but the easiest way is to cross multiply and check. So we're going to multiply the opposites going that direction and the opposites going this direction. And if those two multiplication problems are equal to each other, then they are similar. So let's go ahead and pull out our calculators and check to see if they are. So if we do multiply 75 times 34, we get that it's 2,550. All right, and if we measure or multiply, 50 times 51, we will find, that one also is 2,550. So again, if we cross multiply and they're equal to each other, then they're proportional, and in this case that means they are also similar. Go ahead, pause the video, and copy all of this information underneath your definition into your notebook. Great. Okay, well, let's look at some more examples. Here we have two shapes, and this is kind of a little more challenging because in this case, our shapes look like they're similar, but they're not facing the same direction. So this is going to take a little bit more of evaluating the picture to see if they are similar figures or not. So again, the first thing we need to do is check their angle measurements and see if they are congruent to each other. So I see the very first one I notice is the right angle over here, which corresponds to the right angle over here. Good. Now, if I want to, I'm going to have to figure out where my sides are that are going to line up. So I'm going to go ahead and check this side right here. I'm going to trace this one. And what side does that match over on the other shape? Well, it's going from the right angle over, so I think that's going to match this one right here. Okay, and let's find another one. I'm going to go from the right angle going in this direction right here. So that must mean that it corresponds to this angle right here. And then finally, we have our third line, which is this line right here. And so that must correspond then to this one right here. All right, now that we know that, then let's go back and continue checking our angle measurements. So we already checked that the right angles are congruent to each other. So if I have 55 over here in this corner between yellow and magenta, then if I go to my smaller shape, the corner between yellow and magenta, that angle measurement is also 55, so that's good. And then between green and magenta, I have 35 degrees. And then over here between green and magenta, it is 35 as well. All right, so good. The first things checked is that the angles are congruent. Now let's set up the proportion, okay? So again, we want to identify what we are comparing. And here I have my big triangle compared to my small triangle. So I'm going to set that up. I know that I'm going to do big to small. And now I want to set up a proportion to check if the corresponding sides are proportional to each other and make it congruent or similar or not. All right, so I'm going to say here, let's go ahead and set it up one. So here we go. We said, oops, this is what didn't want to go away. There we go. So we set up our big one. We said 24. So that's our green line over here. Oh, I apologize. Let me grab my pen. All right, so we said 24 right here, and it's on our green line, so it matches our green line over here, which is 15. And then we said 32, which is on our yellow line right there, and it matches 20. So go ahead and cross multiply that side, and multiply that side, and see what you get, and see if they're similar or not to each other. When you did that, you should have gotten that they are both 480 degrees, and that would, or 480 measurement, and that would make them similar to each other. Excellent. Let's do another example. Here we have two rectangles, okay? So we know that in a rectangle, all four sides on a rectangle are 90 degrees. So we already know that their angles are congruent to each other. So now we want to identify corresponding sides and see if they are proportional to each other to make them similar. So what are we measuring? We have our small shape and we have our big shape. So go ahead and identify what we have. In this case, I started with small and went to big. And now go ahead and identify corresponding sides. So I said 18 right here. Oh, I apologize. So I said 18 is in the same location as 25. And that 36 is in the same location as 45. Now, even though they're on opposite sides of a rectangle, we know that this side, XY, has to be congruent to WZ, so therefore 45 would be the same number. And we know that we need to cross multiply So we're going to multiply it going across like this and multiply going across like this. And we want to see if they are proportional to each other. If they're proportional, then they're similar. So let's check. Check with your calculator. Okay, so we see that one side is 810 and the other side is 900. So even though they look like they could be similar to each other, we proved that they are indeed not similar to each other. Very interesting. All right. Tonight, your homework on the Your Turn page is to copy these two examples down. Here you have a set of triangles and a set of rectangles. I want you to use proportions to prove whether or not these figures are similar to each other. Remember to show all of your work. Good luck. We'll see you next time.